Okay, so my name is Loic Quertenmont. I'm doing a PhD thesis at the University of Louvain. My PhD thesis is the search for heavy stable charged particles, which are kind of heavy muons, or basically kind of heavy muons. So it's very massive particles that are produced at the interaction point in CMS, and that basically make straight tracks that go outside the CMS detector, passing by tracker, calorimeters, and muon chambers. And since those particles are very massive, they are quite slow actually. So we can reconstruct those particles just looking at their DEs or at their time of flight, which is slower than a particle going at the speed of light.
And is this what your group is also looking at?
Yes, part of the Louvain activity is the search for heavy stable charged particles, but we are also looking at top physics and forward physics. We have people looking at many things in Louvain. Basically, we are very interested by all that concern trackers and forward detectors. We also have a tier 2 in Louvain, actually the half of the Belgian tier 2 for the grid computing, and some people are also involved in developing tools for that.
And how many people are here working at CERN?
We are around 26 people working on CMS detector, and basically 22 physicists working on it.
And how long have they been working at CERN, and what kind of work have they been doing over the years?
We were quite involved in tracker commissioning, construction, and so on. So one big part of the tracker has been assembly at Louvain, mostly the tech minus part. So we are not the only group working on that. It's a significant part of the tracker.
And so now that the CMS detector is ready and the beam has started, what is the work involving now for you and the group?
So still working with the tracker. We are commissioning everything. We are calibrating detectors, in particular for the DEDX, so the energy loss of the particles. We have one member which will start to be the tracker DPG next year. So we are really involved in all tracker activities and commissioning, which is tough work.
So what exactly are you looking for when you're looking at the data that's being produced by the tracker?
So, for instance, one nice result that we can do very quickly with the very first data are identification of protons, counts, looking at just at minimum bias backgrounds. We showed already some results yesterday. We can try to improve resonance detection using again the DEDX data. This is what I am doing. Of course, I cannot speak for the it's a very important contribution. We can already start to look for heavy stable charged particles, because this search is quite easy to do with first data, because it just involves tracker and muon understanding. It's not too sensitive to the alignment and so on. So we can really start already now looking at physics beyond standard and so on.
And have you found any interesting data over the past few weeks?
We really have many collisions since last weekend, so work is ongoing, but no new physics right now. But we already identified kaons and pions peak and proton peaks. This has been shown yesterday, so it's not new physics, but it is interesting because it shows our detector is working as expected and so on. And data are not calibrated yet, so it's really good that we can extract data and physics from data.
And is the tracker going to be upgraded? Is work already being done to upgrade the tracker?
I don't know anything about that.
And how long have you been? Are you working here at CERN, or do you?
No, I'm based up in Louvain, and I come to CERN when I have to meet people or when doing shifts and so on. So.
And of course, it's CMS week this week.
Yes.
What does that involve?
It involves many meetings, many people. It's quite crowded here, but it's very interesting because we can basically meet all the CMS collaborators the same week. It's important that we have weeks frequently where everybody is here.
And what is the atmosphere like at the moment now that the detector is working, the beams are going?
It's quite exciting. You know, I'm also involved in event display stuff, so just advertisement and so on, and it's really exciting. Just look at the collision data and see what we have seen last night or today. And it's magic because every kind of new event is really magic. We can see first digest event, first tracker event, first forward beyond. So it's really nice.
And I suppose this is helping your PhD studies. How can you just explain a little bit more about your PhD studies and how the CMS is related to this, what you're trying to prove, what you're trying to look at?
So, as I said, I'm trying to identify heavy stable charge particles. I'm mostly involved in the search using the tracker for those particles. So I look at the energy that the particle has lost when passing in a tracker module, so in the silicon. Since the particle is slow, the energy that it loses is higher than standard model particles. So looking at all the measurements of the energy loss, we can see that the particle energy loss is higher than standard model particles for a given impulsion, of course. And this is very easy because we can basically cut the particles with a simple threshold on the energy loss as a function of the impulsion, of course. But this implies many things. So it implies that the tracker is well calibrated. So this is something that we are doing. It's part of my PhD thesis. It implies that the tracker is well understood and so on. It implies that we know also the scale factor from the energy loss. I mean, if we want to reconstruct the particle mass, it's not enough to just have a threshold to discriminate between standard model particles and new physics. We also need to know what this digital signal means in terms of real energy loss. So we need a function, a scale that will go from one to the other, and thanks to that we can reconstruct the mass. So it's also part of my PhD. Smaller parts.
And what would your advice be to other young students who are wishing to pursue a career in physics, maybe work at CERN, maybe study at the University of Louvain?
They have to. I mean, it's really a very exciting moment. I mean, physicists have waited for several years just for the LHC starting, and no, it's just the good period to start. We have data to analyze, and it's very good. If it's really a nice place to study because it's high technology everywhere, from single computers to the fans running in the cavern to the magnetic field. I mean, everything is really high technology. It's very good to be here and share knowledge with experts and so on.
Thank you so much for sharing your time and experience with us.
You're welcome.